Hello and welcome to this Meet Your Future session. In these sessions, we hear from people in different roles and you have the opportunity to ask them your questions about what they do and how they got to where they are. My name is Jamie Sloan and I'm your host today. I work at the Greater Manchester Combined Authority and it's my job to help young people find out more about the different careers and options that are out there available to them. One of the ways that you can do that is on the GMACS website, gmacs.co.uk, which has a lot of information for young people who live in Greater Manchester. Today, though, as part of Women in Engineering Week, we are going to hear from Sugandh Bhatnagar, who is an aerospace engineer with the company Airbus. She's going to be telling you what it's like in her job and how you can get into it. If you've got any questions, please do put them in the chat and we will have some time at the end to answer them. You can also turn on live subtitles by selecting Turn on Live Captions in the menu. I'm now delighted to hand over to Sugandh Bhatnagar and I'm just going to remind her to unmute before she starts speaking.
Thank you so much, Jamie. Okay, hello, my name is Sugandh and I'm here to talk to you about spacecraft engineering at Airbus. So a little about me first. I'm actually a fourth year aerospace engineering student at the University of Bath. I'm on an integrated master's course, so I'll be doing my master's course next year, but for this year I'm interning with Airbus as a general space intern, which basically means I can move around to any of the different divisions within my office and have a look and see what it's about. So it's pretty good. So if I, sorry. Okay. So this is I just wanted to provide a little overview of what firstly aerospace engineering is. Maybe some of you don't know. I definitely didn't know when I was younger what exactly aerospace engineering actually means. A little about what Airbus do, what I do within Airbus, and just how you can get involved with it as well. So what is aerospace engineering? Sorry. So engineering, that's a familiar term. It's just design, development, analysis, testing, and production of a product. But what does the aerospace part actually mean? So you can actually break it down into three different categories. You can break it down into astronautics, aeronautics, and aerodynamics. So astronautics is all about space, so satellites, rockets, that's my job. But you also have aeronautics, which is to do with airplanes, helicopters, drones, anything within the atmosphere of the Earth. And then you've also got aerodynamics, which is much more broad, which means you can go into things such as turbine design, sports engineering, making F1 cars if you really wanted to. So it's quite a broad topic of study that you could get involved with. So Airbus itself, I'm here because it's an aerospace engineering company, funnily enough. So they do they have three major departments within the company. You've got Airbus, which is Airbus Commercial, which does all the aircraft that I'm sure you all know about. You've got Airbus Helicopters, and you have Airbus Defence and Space, and that's the department I'm in. So within Airbus Defence and Space, you've got four major departments, and they kind of overlap in certain areas, such as mine. So I'm within Connected Intelligence, which is to do with communications from a satellite to people on Earth. It doesn't have to be military, but in this case it is. And yeah, it's about designing and operating spacecraft to be able to help a customer, whoever they might be, communicate anywhere around the world. So here you can see the link between the Connected Intelligence part and the space systems, where you've got the telecommunication satellites in the middle and how it's linked to the antenna dish you can see, and that's providing a secure communication channel, which means that anyone on the ground who is accessing that data can access it without fear of anyone else being able to listen in, which is great for many reasons, and particularly for the military. So space systems. So within space systems, there are actually 5 different categories. You've got telecom, satellite, Earth observations, navigation, space science, and orbital systems, all with very different uses of what you could do with space. So you can look at the Earth, see what's going on in the Earth in terms of navigation, monitoring the environment, the weather, but you can also help with communication services like TV, internet, radio, or you can look beyond the atmosphere and go into space science and try and find, for example, the ExoMars rover, which is trying to collect samples from Mars and trying to investigate what's happening on Mars, or even space travel, because that's a new exciting field that we're getting into. So Airbus has a hand in all of these major categories. Connected intelligence, of course, is more to do with the military side of things and providing secure communications all over the world. And we're actually the world leaders in that. So it's pretty cool stuff. Go through some ongoing projects, as I mentioned, the ExoMars rover. So it's a European rover, and it's with a collaboration with ESA, who are the European Space Agency. So they're our version of NASA, probably less heard of just because space isn't that big yet in Europe, but they're very cool people. You should probably follow up on their missions. But yeah, so the ExoMars rover is hoping to drill down 2 meters into the ground and collect samples and basically search for indications of life. So you might be wondering, why is it drilling down 2 meters? Well, it's because the atmosphere of Mars is actually so toxic that it provides very little protection for Earth-like beings or any microorganisms to live there. So we're going to dig deep down to find some signs of life, whatever they might be. So I know it says 2020 on the slide, but because of the whole Russia-Ukraine war, unfortunately, it's been moved to 2028. So hopefully you should be seeing some Martian samples in the near future, which is pretty cool. You've also got the Orion mission, which is trying to get in front of human space exploration. So it aims to go have a crewed mission, so of 4 to 6 people, where it will take them from the Earth to the moon, orbit for 6 days, and then bring them back onto the Earth. And that's a 26-day mission that they're trying to do, and it should be a reusable mission. So it's quite interesting. And Airbus were in charge of the service module, which basically means everything to do with power monitoring, thermal control, providing smaller thrusters to help the satellite stay in the orbit so it can go around the moon, things like that, but also providing water and air for the crew module where the actual crew will be living. So it's quite an important module that Airbus have been fortunate enough to be a part of, and they're actually testing on the Orion right now, so hopefully should launch soon. And then OneWeb is kind of the first thing you'd think of when you think of satellites in Airbus. It's one of their newest, most exciting products. It is a constellation of satellites. So a constellation is just lots of different satellites who will work together to provide a bigger image. So in this case, OneWeb aims to provide affordable internet access all around the world. So actually there are going to be 648 satellites up in the atmosphere just floating around, trying to help give people more affordable ways of getting internet, which is great. Yeah. Another very cool and exciting aspect is the rockets and all the space launches that Airbus also offer through their subsidiary, which is called Aerospace. So rocket launches, you've got different stages that come off depending on the time of flight. And Ariane 6 is actually quite a famous space launcher that's used to get the satellite, which would be the payload, onto the rocket, and then that would be launched up into the sky and then deployed into the orbit that it needs to be at around the Earth. So 2023 is going to be its first launch, which is pretty exciting. So exciting things to come. And then you've got more of the classic missions that you might have heard of, as they've now been completed. So you've got the Rosetta mission, which was back in 2004, and its aim was to land on a meteor and try and make a detailed study of the elements within the meteor to get a better understanding of what the comet actually is. You've also got the Eurostar NEO, so that's to do with telecommunication purposes. So telecommunication meaning just a person on Earth trying to communicate to another place, so the signal goes up to the satellite and then back down to whoever needs to hear it on the other side. Very cool stuff. And then you've got JUICE, which is to do with trying to find icy moons and life again on Jupiter moons, which will be launched soon. And I was fortunate enough to actually see it at its testing phase recently, and it looks like it's huge. Like satellites are huge. I was very blown away by this fact, but yeah, it was very cool stuff. And then again, another space mission just to have basically an ISS easy access, which is really good. So space debris. So this might be a less heard of part of space, and it's basically we're launching all of these satellites up into space, all these rocket launches, but the waste has to go somewhere, and it unfortunately just gets trapped within the orbits around the Earth. So space debris is just any parts of rockets or unfunctional satellites that are just stuck in the orbit and are just waiting to collide with functional rockets and functional satellites. So it's a really big problem within the space industry right now. So that's why Airbus are also looking into ways of disposing of such debris, one being this harpooning type of mechanism where it launches a net to capture the debris so that it can then bring it with itself back down to Earth. For communications again, so I'm within the connected intelligence segment, but obviously also space systems because I'm doing telecommunication satellites. So a bit about my job itself. I'm within the space department at my actual site, where I can go into these 4 different departments. So you've got flight dynamics, space operations team, space engineering and operations, and ground segment. So they are all required in order to operate a satellite. I'll just go through it a bit. So again, as I was saying before, you transmit a signal up to the satellite, and the satellite will then bring it down to where you need the signal to go. It's very simple. So for flight dynamics, they're in charge of planning all of the maneuvers the satellite would need. So making sure it stays within the orbit that it needs to, within the special box that it's been allocated to in the atmosphere, making sure it can avoid all the space debris that I mentioned before. And the flight dynamics team are basically in charge of monitoring that the actual satellite is on the right course around the Earth. And they also have they also look into space weather as well, which is to do with the effects of the sun and solar wind on the actual satellite and how it can affect the operations. You've also got the spacecraft operations team. So this includes the spacecraft controllers, who are the people who will actually be in charge of sending commands to the spacecraft to tell it what to do. So the flight dynamics team prepare the plan, they hand it over to space operations team, the space controllers, who then execute the plan. And they are there 24/7 on rota in order to make sure that the satellite is looked after at all times of the day, and if there are any problems, to let the engineers know so that a solution can be found. You've also got the space engineering and operations team, which is where I'm mostly based, where we look into trying to maximize the operational life of the spacecraft itself. So making sure that the spacecraft is okay, if there are any long-term trends in it, in some faults that we can identify earlier before it becomes a real issue, and we can separate our work into payload and platform. So platform is everything that you would have, such as the power system, the battery, everything essential you need in order for the payload to work. So with all satellites, their reason for existence is the payload. That's why the payload is so important. So in our case, the payload is a communications payload. So the payload needs to be monitored all the time in order to make sure the customer can get their communications across. But platform is also important because it's required in order for the payload to actually operate. So we're in charge of making sure both systems are actually operational at all times. And you've got the ground segment team who are in charge of making sure the ground segments, so the antennas on the ground where the signals are going through, are actually operational as well. So you might be able to see how all of those teams fit together in order to provide 24/7 service for the customer. Let's skip this one. Okay, so early careers. So how can you actually get involved? Hopefully what I've said so far seems sort of interesting. Maybe you want to look further into it, and there are 4 ways that you can actually get involved. So I'll start off with a grad scheme. Might be a bit too far into the future for you guys, but it basically gives you the opportunity to be with Airbus for 2 years, where you can hop around on 6-month placements to whatever part of Airbus you want to explore, which is great because you don't have to settle for one specific role. And you're able to work on a team project, which can either be campus management, which is going into universities and doing STEM events like these, or you can do a technical project like this year it was creating a drone and a rover for military purposes, but it can be it changes every year, the project, so it's very cool. So how would you get to this place in the first place? So you need to do your A-levels, usually maths and physics. You could also go to college and do an engineering sort of role, anything to do with maths basically. Then you'll be able to get into a maths or business related degree, an engineering or science or maths degree, or a psychology or HR degree or business degree. And through those, depending on which ones you choose, as you can see on the slides, you'll be able to apply for different aspects of Airbus. So if you do anything engineering related, that will go to the engineering and operations grad scheme. If you do anything math or business related, you can apply for the finance and business side of things. And then psychology or HR related degrees, you can obviously apply to HR. So even if you don't want to be an engineer, you can get involved in Airbus in lots of different ways and be part of the space era. You've also got apprenticeship. If the university is not for you, it isn't for most people, that's fine. All you need is at least 5 GCSEs with a grade B or a 6 in maths, or grade C or 4 in English, grade C or grade C in science, and you'll be able to apply for the apprenticeship scheme, which means that you won't have to go through university, don't have to have all those loans, and you can go straight into Airbus and they will train you in the 3 departments that I mentioned earlier, and you can work your way up from there. And since we are talking about women in engineering, there aren't that many women in engineering in general, but Airbus have quite a large proportion, with 30% of the Airbus group interns being women. So Airbus definitely cares about employing more women and bringing them onto the workforce in order to have a more to have different ideas and not have the same kind of same sorts of teams who aren't able to think outside the box. And a diverse team allows for that. And so Airbus are definitely looking into making sure that the age isn't a restriction, your ethnicity and so on aren't a restriction, so anyone can apply. So again, you would have to do you can do the A-levels, that's what I did, A-levels, then onto a university degree, and then onto the placement year. So in order to do the placement year, you need to make sure that the university course that you apply to has a year in industry or year placement included within it, and you'd be able to do it as part of your degree. And so for now, what you can very easily do is a virtual work experience, which is really cool. So if you access the link that I've put on this slide on this website called SpringPod, you'll be able to look at have an insight into Airbus Defence and Space, but more specifically on the space side. So you'll be looking at the company's core values, of course, but also trying to look into the development of the ExoMars rover, about zero-emission flight, and testing and building different propulsion systems for the future. And one of the activities that they get you to do is to set up your own moon camp, which is really cool, and they'll help you out with how you should run it, making plans on how you should train your astronauts, so you can feel like you're a systems engineer where you're planning everything out for this camp, which is really cool. And apart from that, it also helps you plan for the future. So they'll help you hear about all career opportunities, Airbus related, help you out with CVs or any sort of applications you want to submit for future use when you're going for an internship or a job or whatever. So it's a great way to get involved, and it's open to everyone aged 14 to 19. It will take 10 hours to complete. I think it's a great opportunity that you guys can definitely take hold of. I didn't know about it until I started researching for this, so definitely get involved. And then if you're just looking for jobs in general in the future, you can just go into the Airbus careers area and you'll find it. But yeah, that's it from me. If you guys have any questions, I would love to answer some. So thank you.
Thank you so much for that talk. That was brilliant. Let me bear with me one moment. There we go. I've lost myself. Okay, I'm back. Thank you so much for that talk. That was absolutely brilliant, and such a exciting array of things that your company is involved with. Just before we get started with any questions, can I just ask, where are you speaking from right now?
Right. I'm really sorry if you can hear music or anything. I'm actually at a pub right now because I'm not allowed to have my camera on site, so I had to take meetings elsewhere. So yeah, just so casually enough.
Not just in a pub for a cheeky lunchtime drink.
No, no.
Because of security reasons.
Yes, because of security.
That's really, really interesting.
Yeah.
Thank you for giving us such an exciting overview, as I say, of what your company is involved in. I think a lot of young people aren't aware that there is so much going on in the aerospace engineering sector in Great Britain.
Yep.
Lots of, everybody's heard of NASA, but I bet not many people have heard of the European Space Agency or Airbus. So there's not really a question in that, but I wonder, can you reflect on that at all? Have you got anything to add about that?
Yeah, for sure. I think the UK has definitely been quite behind in employing a lot of people within the space industry. It's not really a big thing here as it is compared to America. Let's say, as you said, everyone's heard of NASA. Not many people might have heard of ESA. And I think this is the right time to get involved with anything space related in this country, because there seems to be a sort of boom in opportunities where they're actually building spaceports, so places where you can launch rockets with Virgin Galactic. So there'll be plain rocket launches. So the plane takes off, the rockets are attached to the bottom of it, and they get launched from the actual plane itself. So if you want to get involved in cool projects, because they are definitely coming to the UK now, it's the perfect time to start thinking about it and start getting involved in however you can.
Absolutely. And yeah, as you say, it is a growth sector, isn't it? More and
Yes.
more, there's more and more opportunities as connectivity becomes more important. We need more satellites. And you mentioned the OneWeb project, putting satellites across the globe to give us internet. So yeah, so many more opportunities. And when you say a spaceport, I believe Britain's building its own spaceport in Scotland. Is that right?
Yes.
And by spaceport, what we really mean is a rocket launch site, isn't it?
Yes. Yes. So because of kind of the space restrictions in the UK, we can't do what the US is doing with vertical space launches. So you have planes that have rockets attached to them, and the rockets are launched once the planes are high enough and it's safe enough for them to be launched. And I think there's going to be spaceports in Scotland, but also in Cornwall. So a lot more coming up all over the place, which is really cool.
That's brilliant. Yeah. So rockets being launched from Britain. That's
Yeah.
absolutely amazing.
Yeah.
So I was wondering if we could kind of delve into a little bit of your personal relationship with engineering then. So what is it about engineering that you find so exciting? Why did you want to pursue to become an engineer?
I think since I was young, I think it first off the space part came into play more than the engineering side of things. I was really interested in space, and I kind of worked backwards from that. So I tried to figure out okay, I want to get to the space industry. How do I get there? And I seem to really enjoy design and technology at school. I did graphic products. I also really liked maths and physics. So it kind of made sense engineering to go forward, to be able to build things and see them in action and hopefully help people out with them. That's the ultimate thing with engineering. So yeah.
Yeah, I think, and I think something that lots of people don't realize is that when it comes to engineering, that it is actually, and well, I put this to you, let's see if you would agree, that it is quite a creative subject, because you are creating new things and you're solving problems.
Yeah. I would say that's definitely the case. Even in my role as operationals, kind of the operation side, you'd think, oh, because I'm not doing the design work, I don't need to be as creative or um, anything like that. But it's not really the case. There's a lot of problem solving that needs to come through thinking outside the box, thinking creatively. So even if drawing things and doing that sort of engineering isn't for you, there are lots of ways to be creative and be a problem solver and still be part of the engineering community, which I find amazing because it's open for anyone to join as long as you enjoy kind of problem solving and being creative. So it's really good.
Fantastic. And I wonder if you mentioned that you quite liked maths and physics,
Mm-hmm.
but a lot of people, especially girls, can see maths as a bit of a barrier. And I wonder if you can reflect on that at all. Would you have anything to say to someone who was perhaps struggling a little bit with maths? Perhaps it wasn't their favourite subject. I was wondering if you have any comments about that. What would you say to them?
I think I would say kind of sometimes at school it might seem like you're not really sure why you're learning this, and if you aren't able to see the purpose of maths and the algebra that you're seeing, you kind of are like, why am I doing this? I don't really care. I don't understand. But I think thinking about it in an application side of ways is quite interesting. Like, for example, the Pythagoras that you do, very simple stuff that you've done since you're very young, that can be used in trying to figure out where a satellite is in its orbit. So it's those little things can actually, they all have a meaning at the end of the day. So it might seem like, oh, I don't know why I'm doing 10,000 questions to do with Pythagorean theorems and stuff. But I know it's hard because you're young, but you have to think about it as what kind of ways can I use this maths in my daily life? Like, why would I ever need to use this in the future? And I think you'd find with engineering, especially maths, it goes very hand in hand. And you can make it fun for sure. There are ways to make maths fun as well. If you find it quite boring to do exercise after exercise, there are great resources online. Even your teachers, I'm sure, would be very happy to help you out with being more engaged with maths. Or if you're not understanding things, just ask. It is hard, but it's supposed to be hard because it helps you get that problem solving side of your brain on, which will be really useful in the future. Even if you don't do engineering, you can use maths with a lot of things. So yeah, it's just about giving it a go, knowing it's hard, but doing your best with it and asking for help whenever you need it.
Fantastic, thank you. That's really wise words.
Yeah,
that's really brilliant. Thank you.
Yeah.
And another thing is that some young people can feel that science and engineering is reserved for clever people. Now, do you consider yourself a clever person? Are the people that you work with, are they clever people, or do they sometimes do stupid stuff like the rest of us?
I think everyone does stupid things. I think the thing with adults is it kind of seems like, oh, everyone knows what they're doing. But I think the secret is no one really knows what's going on. No one really knows what they're doing. I think we just try our best, and that's all that it's about. Just using as much knowledge as you do have in order to make whatever thing you want with engineering. I would say definitely, I don't think I'm very clever. I think it's just about just finding ways in order to help yourself learn the things you do need to learn and doing your best with it. You don't need to be clever to do engineering. You just need to have fun with it. Like if you enjoy problem solving, it's a fun activity to do every day. So you don't necessarily need to be the standard clever to do it. You just need to have that particular skill in order to do it. And if you can't do problem solving, you can be creative. There's room for that as well. So yeah.
That's brilliant. So you gave us some of the different options that people could get involved into your industry if they're interested.
Yeah.
And am I right in thinking that you did A-levels and then went to university to do engineering and are now on an internship? Is that right?
Yes.
And when you did A-levels, what A-levels did you choose?
Okay. Yeah, I did A-levels. I did maths, further maths, physics, and design and technology. You definitely don't need to do further maths. It was a bit overkill on my part, I have to say. So if you're scared of maths, don't worry, you don't need to do further maths. I did those, and then I've applied for aerospace engineering, which it's kind of one of the only courses that would let me do spacecraft engineering related topics, which is why I went for it. But I also know loads of people at my office who have a physics background or a maths background, or one person has done microbiology and is now on the payload team. So really, if you are interested in space and problem solving, you can get in if you have the passion for it, because that's what the space industry is really looking for, people who are passionate and want to get involved.
That's fantastic. Okay. So we've got one more question so we've answered a few questions that we've had come through, and I must admit I have to apologize. There wasn't a little pop-up, so I didn't see that we had questions come through, so I apologize, but it looks like we've answered a few of them. And there's another one that we've had from Sarah that says, what does your job entail on a day-to-day basis?
Okay, so if I think of it from a spacecraft engineering point of view, so my whole purpose at work is to make sure that the satellites we have are okay. So if I get into work and I notice there's an out of limit, so that means one of the temperature values or something, current value, something on the spacecraft isn't correct, is out of its threshold, I then have to investigate, okay, why is that? So I need to look at the telemetry, so the data you get from the satellite, investigate, okay, why is this out of limit? Is it because of the space weather? Is it because of an operation, like with procedure we've done onto the spacecraft, or is it because the actual machine is broken, or is it because of something else? So you have to look into the spacecraft, understand how it works, ask people. Usually it usually helps to ask other people who are more experienced about what they're doing, about what they think the problem could be, learn from them, etc. But actually, surprisingly, I'm doing a lot of Python work, so a lot of coding in order to help look at the long-term trends, so see if there was a problem earlier on that has been propagating, so that has continued being a problem, but we haven't seen as an issue because it's been a gradual change in the value over a long time. So it's about kind of having scripts that are able to identify that and investigating into why that is. And I think that investigation is the problem solving part that I love doing. So if you enjoy that, I think you really enjoy the investigations.
So you are basically responsible for keeping satellites up there in space? Yes,
and making sure that they stay there as long as possible. For example, the satellites that we build are only meant to be up there for like 15 years. That's their operational time, but we've seen satellites that have been there for much longer, and that's because of the engineers making sure that the fuel that we have on board is okay, all of the electronics are okay, because if there have been out of limits, we've identified them, we've tried to solve the problem. So yeah.
That's very, very cool. Okay, so I'll just give a couple of minutes to see if anyone else has got any questions. Hopefully we've answered all of the questions that you have asked already, but please do put in the chat if you have any more. Teachers, I have added a link to a feedback form, so please do let us know what you thought of this session today. We're not getting any more questions coming through, so I think we might leave it there then. Okay, so Sugandh, thank you so much for taking the time out of your day to speak to us. That was absolutely fascinating, and what you do is really, really interesting. We hope that all of you out there have enjoyed watching and found the session informative and useful. Thank you so much for joining us. Sugandh, do you have any final words that you want to say?
First of all, thank you for having me, and I hope that even if you're slightly interested, just look into it, give it a go. If it's not for you, it's not for you, but at least give it a go and see what happens, because you might surprise yourself.
That's wonderful. Sugandh Bhatnagar, thank you so much for joining us today. Don't forget, everyone, you can find out more about careers and options on the GMACS website. That's GMACS. Other than that, though, thank you, and join us again for another Meet Your Future session. Goodbye.